Hello and welcome to this tutorial. So today we are going to discuss on introduction to number system. So we will going to talk on the analog and digital systems, analog and digital numbers. Then we're going to talk on the binary, decimal, octal, and hexadecimal numbers. Then Boolean algebra, and then slowly we will switch on to the digital circuits. So let us switch back to the screen. So you all can see the screen here. Okay. So before going into the number system, let us discuss what is analog and digital signal. So whatever the signals that is available in the nature, that is an analog signal. For example, you take the temperature, the variation of temperature, or the pressure, humidity, everything, it varies with respect to, say, time t. So this I can plot it. So your x-axis will be your time t, and these variations might be the change in temperature. So this is magnitude. Now, uh, most of the times in the communication system, we may use these analog signal itself to transmit. But nowadays, what we are doing is we are not transmitting these analog data. We are going to sample these analog data. We are going to sample it at fixed interval of time. Say this time period may be called as some fundamental period t. And if we sample these with fixed interval of time, we will get these in terms of samples or discrete signal. So if I can plot here these samples, then I'll get something like this. So then I will, so this is in the discrete form with different magnitudes. So then we will do this quantization and coding, and after coding it means we are converted our continuous time signal into a digital signal. So the conversion involves basically the three steps. So let me write down here. Conversion of analog consists of three steps. So it consists of three steps. So first one is sampling, second is quantization, third is coding. We will not go much in detail of this, what is quantization and coding. So because again it will take a lot of time there, so that is not our scope of this video. So I'll just give a glimpse here. So for example, here the maximum peak of the signal is, say, in terms of voltage, say 8 volts or say 7 volts. Then whatever the sampling we have done, we'll approximate this to nearest level if we split this into 8 levels. So for example, we split this into 8 levels. This is 0, this is 1, this is 2, this is 3 and 4, like that up to 7 we have. So 8 levels we'll get. So here for example, if this is at 3, then if it is at somewhere at 2.9, then we'll approximate this to 3. If it is somewhere at 4.1, we'll approximate this to 4 volts. So this is called something quantization. So there is a small quantization error which is involved here. So after that, each of these levels are converted into binary. For example, the 0 voltage level will convert to 0, 3 zeros, and the 1 voltage level will convert to 0, 0, 1. So likewise, the 8th level will convert this to a binary in terms of 1, 1, 1. So this is nothing but a coding level. So this is just a basic introduction. I will not go in much of the detail of this. So this is how we will convert analog to digital. Now these digital data we will going to transmit in the communication channel with the help of again some kind of a carrier signal, so which will be continuous again. Why? Because today, nowadays, there is a lot of digital circuitry which is there in the market and which has got a lot of scope. So that is why we have to convert our data into the digital format, because these devices can able to handle the data in the digital format. Okay. Uh, So now this is about the analog and digital systems. Now let us look into the number systems here. Can you all see what I am writing on the screen here? Yes. So that is fine then. Now let us see the number system here. So there are different number systems. So normally in our day-to-day life, we'll use the basic decimal number systems. So whereas the computer system use the hexadecimal systems. Whereas there are other systems also in between like octal numbers and binary numbers. The computer basically understands the binary number, and at high level we deal with the hexadecimal numbers. So now there is the first one is the decimal number system. So second one is the binary number system, third one is octal number system, and fourth is hexadecimal number systems. So these are the different number systems. Sorry, I missed here one letter. So this is decimal, binary, octal, and hexadecimal number systems. So we're going to talk about these individually, and then we will see the conversion of decimal to binary and each of these conversions. Okay. So what do we mean by a decimal number system? So we will represent this any number with respect to as base of it. For example, any number we write here, so that is represented as in terms of base 10. So now for example, if I write some numbers, say 25 to base 10. So how do we write this 25 to base 10? So this is nothing but this is equal to 2 into 10 to the power of 1 plus 5 into 10 to the power of 0. So when we simplify this, what do we get here? So here we will get 20 plus 5 equal to 25, right? So this kind of representation means the unit, tens, hundreds, and thousands. So this is how we used to represent in the decimal systems, right? So this is the basic decimal number representation. So let me save this page. So page 47. Let me take the new page here. So let us talk about the binary number system. So binary number system, it has only two digits, that is either 1 or it is 0. So it has only two numbers in it, whereas the decimal numbers has 10 numbers, that is 0 to 9. So that we will see later. So now this is 0 or 1. For example, this can be written as in a binary combination of any number 1 0 1 1 point. If there is any decimal point, then 1 1 1 0, something like this as base 2 representation. Then let us look into the octal numbers. So octal numbers has 8 numbers in its sets. Octal has, okay, octal number system. It has 8 numbers in its sets. So basically it has numbers from 0 to 7. Okay. So this can be any number that can be represented as base 8. For example, 4, 5, 6. This can be represented as base 8. Can I write 974? Can this be a octal number? Is this right? No, it cannot be an octal number, because if you see this number 9 is not within the range of 0 to 7, it is greater than 7, so this cannot be an octal number. So we have to be very particular when we are writing this or solving the octal numbers. Okay, so now let us look into the hexadecimal number here. Hexadecimal number system. So hexadecimal number system will range from say 0 to 9 and A to F. After 9 it goes like A, B, C, D, E, F, So that is the representation. So any number like this, for example, I can write this as A345 dot uh, F3BC. So this is a hexadecimal number, so this can be represented as to the base 16, right? So these are the hexadecimal numbers. Now let us look into all together all of this in the next page. So let me save this page here. So page 48. Okay. So now let me write here the decimal number. Next, let me write here the octal number. Next, let me write here hexadecimal number. Then let me write here the binary number. Okay, now let us see this all together side by side. How does it look? Now, let me put a straight line here and let me select the thick line. Yes. So like this, like this. Okay, right. So now if I write say 0 0, what is the octal number? It is also a 0 0. So hexadecimal, it is also a 0 0. What is a binary number? Binary number is 0. Now in decimal if I write this is 1, then octal number is 1, hexadecimal number is also 1, binary number is 1. Now if I write here say 0 2, this is 0 2, this is also 0 2, whereas here the binary number there are only two numbers 0 and 1 I have written. So what to do? So for that I have to add one more digit here. So when I add one more digit I can write this as 1 0. So it means after 0 0 0 1 the next number is 1 0 in binary, that is equivalent for 2. So now if I write this as 3, and here also it is 3, so here it is 3. So then what happens here in this case? Now it has become 1 1. Now 0 has become 1. Now this 1 has remained as it is. Now if I want to write 4 here, so this is 4, so this is also 4, this is 4. So now there are no more numbers to change here in the binary. So what I need to do, I need to add one more binary digit here to its left. So now I have to make this one, now I have to make this again changes to 0 0. Then if I write this here 5, so this is also 5, so this is 5. Then what happens to this binary number? So this will be 1 0. So this, it will always start the changes from the rightmost bit here. So rightmost bit is 0, so now it is 1. If it is reached the maximum 1, then the next bit will change. So accordingly you can think like that. So next it is 0 6, so this is also 0 6, so this is also 0 6. So now this number has become 1 1 0. So next is 0 7, this is 7, this is 0 7, this is also 0 7. Now what happens to this? So I'll get here 1 1 and 1. So now next let us write 8. So what is the next number in the octal? Can anybody tell me? After 7 in the octal, what is the next number? Anyone? Can you hear me? The next number in the octal after 7, it has reached its maximum value. So this will become reset to 0. So then the next digit will come into picture. So the next digit will become 1. So it is become 1 0. Whereas here still it has the range, so it will continue. So next number is 8 here. So whereas here in binary it has reached the maximum. So no bits can change to anymore else. So what I need to do is I need to add one more digit here. So I need to add one more 0 digit here. 0 0 0. So now what happens? So this will become 1. So all of the bits will reset to 0. So now when it reaches to 9, then this will become 1 1. So this will become 1 1, and this will go to 9, and then this will become 1 0 0 0. Sorry, it is 1 0 0 1. So next, when it becomes, now it has reached its maximum number, so what happens now? The 9 will reset to 0, so now the one more digit will come here, so that will become 1 0, and here this will be 1 2, this will be, now it has reached the 9, so next digit is a here, so it is a, so now this will become 1 0, so now it has reached its maximum, now next digit has to change, so this is 1 and this is 0. So now likewise I'll just move this data here to a little aside so that we can write our next digits here. So I'll move this. I'll move this aside. Anyway, this, let it be as it is. So now after this 10, so next I'll write here as sorry for that. So next I'll write 11. So here the last number was 12, so now it will continue as 13. Now it was 0, yeah, now it is 0. I think we have missed something. Yeah, it's correct. So it's B, so now it will be B. Now what about this bit? So okay, let me shift this one also. And I'll erase this one. So now the next binary digit will be 1011. So now if you write 12 here, so what will be the octal number? So equivalent octal number will be 14 and the hexadecimal number will be 0C. And here you can see that this is 1101. So then 13, so the equivalent number here is 15, then here it will be 0D, and here I'll get 1, sorry, this is 1100, and here I'll get 101. Then next number is 14 here in decimal, then in octal it is 16, and hexadecimal it is 0E. Then in terms of binary it is 1110. So then here it is 15, then here I'll get this as 17, then here I'll get this as 0F. So this is 0F, and then here we have reached the maximum number as 4 ones. Now next number here it is 16. Now can anybody tell me what is the next number in the octal after 17? So here the next number, now it will reset to 0. Now one more carry is added to this one, so now this will become 20. Now here it has reached the maximum. Then what is the next number in case of hexadecimal number? Now it will become 0 and it will add a carry and that will become 10. And here we have reached maximum, so I need to have one more bit here, that is 1, and followed by 4 zeros. So now it has become 5 digit. Like this it will continue. So like this it will go up to maximum, say up to 2 7 again, 2 8 it will become 3 0. So then likewise this will follow 1 0 2, 1 F again, then after 1 F, so this will become 2 0, and likewise this also follows from, say, from this to all 5 ones, and then one more digit is introduced here, so then it will becomes 1 followed by 5 zeros. So like this the number systems is continues, and these are the equivalent numbers. So now let us look into the conversion of these numbers. So let me save this page here. Page 59. Now let us talk about the conversion of decimal to any base. So let us see the conversion of decimal to binary first. How to convert a decimal number to a binary number. So for example, it is asked to find the to convert this 298, to convert this number 298 to the base 10, to convert to a base 2 number. So to convert this to any base, for example, if you are converting from a decimal number to any other base number, then we have to divide with that base number till the last value. So for example, here we are keep on dividing by 2, and we will take the reminders here as a collection of these numbers of binary. Now for example, 298 we'll write like this. So 298, let us divide this. So here 2 1, so we have these terms. So 2 4s are 8, so we have one question. So 2 9s 18. So what is the remainder left? So remainder left is 0, so we'll write like this. So then again we will take this 2 again, divide this 149. So 2 7s are 14 here, then 2 4s are 8, so we are left out with one reminder, so you write down this 1. So then once again we divide this 74 by 2, so 2 3s are 6, and then 2 7s are 14 we'll get. 2 3s are 6, so 1 is there, so 1 it will become 14, so 2 7s are 14, so reminder is 0 here. So now I once again divide this number. So 37 divide by 2, so we have here 2 2 and 2 8 is 16 we have, so we have left out with one reminder. So then 2 9s are 18, so then the left out with 0. So then let us divide this 2 3s 9, so the reminder is 0. Then let me write here. So then 3 is 0. So then once again we'll divide this 2 1s 1, so it is reminder is 0. So now we have to read like this in a reverse order to write this in terms of binary. So this we already read, so we'll not write, will not read this because it leads to confusion. Now what is the equivalent binary value is 1 1 0 1 0 1 0. So this is the equivalent binary number of 298 decimal number. Sorry, I think we have done some mistake here. 2 9s 18, then 2 3. Okay, sorry, there is a mistake here. So let me erase this. This is not correct. We have done mistake from this point. Sorry for that. So 2 8 2 4s are 8, so we have a reminder 1 here. So then 4 we got reminder 1, so I'm writing here. So then 2 2s are 4, so reminder is 0, then I'll get 2 1s are 2, then reminder is 0. So finally we'll read like this. Then the equivalent binary number is 1 0 0 1, as we already read here, so we're not going to read again. So this is 0 1 0 1 0. So this is the equivalent binary number for 298. So let us have one more example now. If this number is in terms of a floating number or a decimal point number here, so let us save this page. Okay. Right. So let us take one more example here. So for example, 48.75. 48.75. So how to deal with this number 48.75? How to convert this to a binary number? So to convert this binary number, we have to separate these numbers. So 48 we have to write separately, and 0.75 we have to write it separately, and we have to deal it separately. So now first let us find the binary number of this 48. It's the same way how we did in the previous example. So 2 2s are 4, 2 4s are 8, so reminder is 0 here. So then 2 1s 2 and 2 2s are 4, remainder is 0, and 2 6 are 12, remainder is 0, and 2 3s are 6, remainder is 0. So then 2 1s are 2 and remainder is 1. So binary, so finally we'll get this as 1 1 0 0 0 0. We'll get 4 zeros, right? So now to deal with this decimal value, that is 0.75, what we have to do is we have to keep on multiply this with 2. So multiply this with 2, we'll get this 1.50. So we'll take the number as 1. So then we have to remove this any number which is on the left side of the decimal point. So we omit it. So and we'll consider only that 0.50. Again multiply by 2. We'll get this as 1.0. So then we'll get this as 1. So like this again we can keep on continue how much decimal points we want. So basically we have to read from this top to bottom, whereas here we'll read from bottom to top. So now we put a decimal point here and write 1 1. So this is the binary equivalent number of 48.75 in binary. So this is how we can convert it. So like this you can take any number and you can practice for the conversion of decimal to octal. Sorry, decimal to binary. So now let us see the conversion of decimal to octal. Let me save this page here again. Okay, let me take the new page. So here we'll see the conversion of decimal to octal. So here you may need to use the calculator for the calculations. So let me open up the calculator here. I'll just keep the simple calculator. Date conversions are not required. Basic. Okay, if required I'll use this. So let us take a number here. So this is 946 base 10. We need to convert this to base 8. So as I said, if any number, if you want to convert from base decimal to any other format, then we have to keep on divide with that respective format which we wanted. So here it is a octal. So octal means it's a 8 number. It's a base 8. So let us keep this dividing by 8. So let us write here. So in calculator how we can do is that, so this we can write this as 946 divided by 8. So it means it is we have to calculate here. So 8 into 8. So 8 in it is oh, like this. Let me clear this. So I have to check 8 into 118 something. We'll get somewhere closer to this number. So we have to just do a trial method and we have to find out like this. So it means 118 if I use, so we'll reach somewhere near to 944. So 944 we'll reach, so the difference is 2. So we'll write the difference as 2. So once again we take 8 here. So now so 8 into say 15, which is 120, which is greater. So it is just a random guess. So it is 8 into let's take it as 11, 88 less. So 8 into, let's take it as 14. So yes, we have reached to 114. So I can use this. So 14. So the difference is 112, 118 minus 112. So the difference is 6. So let us write on that. So now this is 8. So 8 1 is 8. So the difference is 6. So once again we'll read this from the bottom like this, and we'll write this finally the number as 1662. So this is the octal equivalent number for 946. Okay, so let me save this here, this page. Now let us see how to convert the decimal numbers of base 10 to base 8. Let us take an example here. So let us take an example of 0.952 to base 10, which is equal to, let's see what is this number. So it is same thing, anything which is in terms of point to the right side, then we have to multiply this with respect to the base we wanted. So then we will get this as 0.952 into 0.952 into, this is 8. So what do we get here? So just use a calculator and calculate it. So it is 0.952 into 8. We'll get this as 7.616. So as I told, anything which is left to the decimal point, we have to omit it. We have to write it down separately and just take the numbers on the right of the decimal point. So we have to write again 616 into 8. So multiply with 8 again. So what do we get? So 0.616 into 8. So you'll get 4.928. So write down this 4 here. So then you take 0.928 here into 8. So again, let us multiply this 0.928 into 8. So you'll get this again 7.424. So write down this 7 here. So like this we can continue up to any decimal point. So in the examination they will specify, so find the number up to 2 decimal point or 3 decimal point. You have to go up to that many iterations. Now if it says a 3 decimal point, it means you have to calculate here 3 times 3 iterations and then you have to stop it. Otherwise it's go to infinite level. So don't waste your time. So finally this we will get this as point, we have to read from the top, it is 747 to the base 8. Fine. So now let us look into the yes, so we will start with the last 14 minutes. Let me quickly look into the conversion of decimal to hexadecimal number here. So let me save this page, page 53. Okay. So let me write here decimal to hexadecimal conversion. So that, let us take an example here. So 8492 to the base 10, we have to convert this to the base 16. So how do we convert this? So we'll convert this in the same way, keep on divide by 16 here. So 8492, divide this by 16. So again it's a random guess we have to start with. So 16 into say 9, we will get very small numbers. So then 16 into 15, we are getting very small number. It means we have to go for a bigger number. So let us say 16 into 500 somewhere. So we'll get 8000. We are somewhere close. So then, or you can just divide this and see the quotients where we are getting nearby. So then we can use that as a quotient. For example, 8492 divide by 16. See, we are getting this quotient 530. So it means we can use this 530 straight away. So now 16 into 530, you just see. Okay, we are getting very close. That is 840. So let us take this as 530. So calculate what is the difference from this number and this number. So then we will get a difference of say 12. So 12 should be written as C. Don't write it as 12 because here we are talking in terms of hexadecimal. So then now let us divide this 530 by 16 again. So I'll get the quotient 33. It's very close. So just 33 into 16, we will get 528. Yes, we are very close. So it is 520. Sorry, that is 33 we will get. So then the difference is 2. then 16, you divide the 33 by 16, we will get here somewhere 2 and close to 2, and we will get a remainder as well. Now again we have to read from the bottom. So the number is 2 1, so the number we will get it as 212c to the base 16. So this is how we can convert the decimal to hexadecimal number. Okay, you are all listening there. Hope you all have understood this topic. Let me quickly jump into one more subsection of this, like conversion of this from a decimal, from the fractional number of to hexadecimal number. Let me save this page. So page 54, and let me take the new page here. So let me take an example here. So if you want to convert, say, this fractional point here, 0.593 to the base 10, if I want to convert this to hexadecimal, it's the same thing here again. We have to keep on multiply this number from 16, right? So multiply this number by 16. So let us see what do we get here. So we'll get 9.4, we'll get 9.488. So anything which is on the left of the decimal point, so write down separately and omit it in the next calculation. So just take 0.488 and multiply it by 16. So we will get this as 7.808. So then we will get this as 7. So likewise we can continue up to any number of decimal points here. So this is again 0.808 into 16, which is equal to, I'll get this as 12. See, this is very important here to note. This is 12.928. So when we get 12, we should not write it as 12, we should write its equivalent number, that is C. So finally when I write down, we have to read from the top here. So this number is 97C. Okay, the number is 97C. So this is the equivalent, sorry, 97C, it is 0.97C, my mistake. It's a 0.97C to the base 16. So hope you all have understood. So in between, please ask me queries if you have any doubts, so that we can discuss it then and there itself. Okay, so thank you for watching this tutorial. We'll join up in the next tutorial. So I'll take a quick poll then.